Okay. All right. Are we good now? Okay, it was also like frozen. Okay, so once again, we're going to do 13.3, line of best fit. We're going to draw, we're going to estimate the line of best fit through the scatter plot. The best fits the scatter plot data through the middle of them. We're going to calculate on the calculator, and then we're going to interpret it with the words in the context, in the situation, in the word problem or context. Okay, it's only going to be on one page. Page 62, so turn to that page. Okay. I'm going to do 13.3, line of best fit. Okay. And since it's linear, it's a line of best fit, it's in the form y equals mx plus b. Okay. No weird forms, just y equals mx plus b, just slope-intercept form for these. Hooray. Okay, and then once you have that written and filled in for your title and you have your page numbers, then go ahead and get this sheet that I just passed out to you. Okay, or if you're at home, you need to get this sheet printed off of the daily directions, because this is what we're doing today and going to glue into your notebook for 13.3 lesson. Okay. I can't zoom in, but that's okay. You guys have the paper in front of you. All right. So we have a set of data up here. We have the points plotted on the scatter plot, okay, because they're not in a straight line, but we are going to make a best fit line through those. And then also all 14 of these points have been put into a table for us, okay? So the first, number one, says to draw a line of best fit on your scatter plot. Okay, everyone's line of best fit is going to look a little different. Okay, try to draw it as straight as you possibly can. If you have a straight edge, that's even better. And which I could use this probably, this little piece of cardstock. Okay, but I'm going to draw it. No, I'm just going to freehand it. I'm going to draw it somewhere through the middle. You're not going to like connect these 2 points, okay? That's not your goal, to connect points. If it happens, it happens. But your goal is to try to draw a line that goes through the middle of these points. So I don't know, maybe like that. Yours is going to be a little different looking than mine. Okay, we're not all going to have the exact one because we are estimating it. We're just drawing that trend line somewhere through the middle of the points where you have about the same amount above as you do below. Okay. All right, check that one off. I did number one. What is your estimated y-intercept, and then what does it mean within this context? All right, well, what's a y-intercept? Axis, yep. So wherever this, our trend line, our line of best fit, wherever it hits this y-axis, this is the y-axis, this is the x-axis. So this right here is my y-intercept. Okay, that's my y-intercept. Yours might have not been right there. It might have been a little bit above, a little bit below. Okay, let's just all go with the same thing for the numbers' sake, so that we're all looking at the same numbers. So if I estimated the y-intercept, about what is that point? Because these are going by tens. What would you say that is?
13.
13? I'm good with 13. So the y-intercept is about 13, right? And what does it mean in the context? So I know that 13, a y-intercept of 13, means that this line of best fit crosses the y-axis at about 13. But what does that mean? What's going on in this problem? What are we talking about? Here's my x's, and there's my y's. So the amount of time from the initial measurement, so time is in hours, and then the length. So what does 13 mean if we're talking about as time goes on, the length of something is obviously increasing, right? Where are we what? the starting time. Okay, so at the starting time, or in the beginning, what do we have? We have 13 centimeters, right? Maybe we're starting to measure a flower or a plant. Okay, maybe you can think of it like that. Maybe we're measuring a flower or a little plant that's grown. And we've started and it's at 13 centimeters. Okay, that's at the start time. That's when we began measuring it. It was 13 centimeters. Okay. So when it says, what does it mean within the context? That means take the words, those units, and put them in there. Don't just tell me it's the y-intercept, it's where it crosses the y-axis. Okay, use the words. Now we're going to estimate the slope using 2 points on your best fit line. And then what does the slope mean within the context? Okay, so 2 points on the line of best fit. Okay, so I have a point right here. And even if you draw a line of best fit and there aren't any of the actual data points touching it, just make up your own points on the line, okay? Don't try to choose data points. Choose the data points if it hits on the line, but if it doesn't, make up your own points on the line. So I could use, you know what, I'm actually gonna use some that I know for sure. So I'm gonna choose that point because I know for sure that's 20 and I know for sure that's 20. And then I'm gonna go up and I'm gonna use a point right here because I know for sure, well, that may be been a little too high. I know for sure that's 30 and I know for sure that's 60. Okay. Now, I'm gonna use the method that Nick said on the warm up. I'm gonna use rise over run. Okay, I'm gonna use rise over run between 2 points on your best fit line. Okay. So I didn't choose 2 points that were the data points because I want you to know that you don't have to use the data points. You can just make up your own points on the line, and I chose 2 points that I knew for sure what the x value and the y values were. Okay? So what would you estimate, because we're all just estimating here, but let's estimate with the same numbers. What would you estimate the rise to be between those 2 points? What's this rise? We're going from, yeah, right? Because that was supposed to be down a little bit. So about 10? The rise is about up 10? And then what's the run? 40 from 20 to 60? Which we can simplify that down to? 1/4. Okay, so that's my slope, my estimated slope, 1/4. Now what does the slope mean within the context? 1 what every 4 what?
1 centimeters every 4 hours.
Right. Increasing. Okay, so again, if it's the plant, right, it's growing, it's increasing 1 centimeter every 4 hours. That plant is growing. Okay. Now, y'all should be able to do this easily. Estimate your correlation coefficient. Give me what you estimate. What place are we going to round it to? Oh, yesterday was 100,000th place. Okay. Based on how close those points are to the line, what would you say the correlation coefficient is? Let's guess together. It's pretty strong, right? I'd say it's strong, not a 9. You want to do a 7? Okay, maybe a 7 and then like higher 7. Okay, so R equals 0.786. Okay. We're gonna say, and I like to do these little about. We should say it's about. We don't know. We're estimating. 0.786. Okay. Because these scatter plots are not too far off of the line, okay, just a little bit. So maybe you were thinking 0.8, we did a high 0.7, okay. And it's positive. So now I want you to think about describing the relationship of the data values based on that correlation coefficient. What is that correlation coefficient? We said it was pretty high. What does that tell you about the relationship? Okay. What is strong? The relationship. Okay. So, strongly related. Okay. Let me say this, as time increases, what happens to the centimeters? Centimeters increase. Remember, it's a positive correlation. Remember, this is a positive 0.786. That tells me as the x increase, the y's increase. Okay. So it has a strong positive relationship. Okay, they are strongly correlated. Here's the fun part. Okay. Oh, so let's write our line of best fit. I didn't even put that in here. Let's write our estimated line of best fit. Oh, yeah, using a calculator. Okay, so before we use the calculator, let's do our estimated line of best fit. Okay. Estimated line of best fit. Boom, boom. Y equals, what do we come up with our slope? 1/4? Okay. Your graphing calculator is going to graph it in decimal form. Okay, so what would 1/4 be as a decimal? 25. All right, so I'm going to say 0.25x plus what? Plus 13. All right, so that's what we estimated. Let's actually see what it is. Let's calculate it on your calculator. Do you remember how to do this? Okay. So I got my calculator. So here's my table up here. Here's my table. Where do I start? How do I start this? Go to stat and then edit. All right, I need to clear these out. So I'm going to go up to the list and hit clear enter. Okay. Do I have enough calculators in here? I forgot my calculators from my other classroom. I need to go get those. While y'all are doing that, because some of y'all might be a little slow. I'm a quick walker. All right, so let's see here. Oh gosh, these are so many numbers. 0, 4, 8, 28.
0.937 or 0.938.
Okay, so I got all my data in. Then I'm going to go back to stat and then calc. And I run number 4, which is a linear regression. Enter, enter. Okay. Whoa, would you look at that slope? What's the slope?
Very big.
No, 0.25. Our slope was 0.25. We guessed that. We didn't guess that. We estimated it correctly using our calculations. All right, so here's the calculated line of best fit. I'm so impressed with our slope skills there. All right, so y equals 0.25. You could even say 0.251. X plus what? 18? 19? Right? So in your calculator, it's going to say y equals ax plus b. Whoop. Okay. Your calculator does not use m for slope, it uses a. And then, so it tells you it's a linear regression, it's a line, this is slope-intercept form. And then it's saying a is your slope, and you can just round it to 0.25. And then it tells you the b value, your y-intercept's about 18.8, and we can just round that to 19. Okay, so our calculated line of best fit, I'd say we did a pretty darn good job. I don't think I've ever calculated it that close before. 0.25x plus 19. So we were really close. Okay. We were a little further off than I thought we would be for the correlation coefficient. Okay. Do you see? So this is the estimated correlation coefficient. I'm back up on number 4. And then the calculated one is R is equal to positive 0.938. So it was a lot stronger than I thought it was, or we thought it was. If you thought it was 0.9 something, well, good job for you. I thought it was 0.8 something. Okay. Oh, it says discuss your estimated values compared to the calculated. Well, we just did that. Look above. Huh? Look above. We just discussed it. Okay. So our estimated compared to the calculated one, okay, it was stronger than we had guessed it. Okay. And then we did a really darn good job of calculating that line of best fit. Okay. Just had the y-intercept off a little bit, which means that my line probably should have been a little bit more angled this way. Angled this way a little bit more. Okay. And maybe, yeah, going through this way. Okay. But good job on that. Okay. So take that, fold it in half, glue it into your 13.3 notes. Uh-huh. Yeah. Yeah, if you didn't get that on your calculator, you need to use this. She's the one that says AX plus me. I was like, that's so weird. Why is it doing that? I don't know why anyone would want that. Okay, so now I'm going to have you guys working on some Khan Academies.